Okay, so picking up where we left off from video 1, here's nuclear notes number 2. I was describing where we can find nuclear fusion. Nuclear fusion is the lesser used version of nuclear. When we talk about nuclear, we're usually going to talk about the second one for most of human history. That's because nuclear fusion takes a lot of energy to do it. It happens in the stars and in stars like the sun. We do use it for hydrogen bombs. A lot of our bombs use it. And we are doing more and more research into what's called cold fusion, where you use a couple other principles to lower the heat needed so that we can do it here on Earth. Because it's really hard to get to those temperatures like at the center of the sun here on Earth. It's just extremely difficult to do. We're becoming more successful with it. I'll talk about that a little bit later on. Fusion is extremely efficient, but difficult to manage. So basically, fusion has almost no problems with it if you can get it to work. It has no byproducts, there's no dangerous waste, but it's very difficult to get it to work. In fact, the very first nuclear fusion reactor is scheduled to start up in Europe this coming summer, the summer of 2021. They're scaling stuff up. So they started with a really small one 2 or 3 years ago that could power like a room. It had enough power to power like a laptop and a couple of light bulbs. Now this next one, 2021, they're going to fire one up that can maybe power like a whole school building. They're going to let that run for a couple of years to make sure they got the process down. And right now they're hoping to get a true nuclear fusion reactor that would power a city going by maybe 2030 is their goal date. So that's kind of a cool side note. The other type of nuclear reaction is called fission. Fission is what most nuclear power plants have used up to now. Fission uses stuff like uranium, if you've heard of uranium before, and then splits it apart. So nuclear fission is when one nucleus splits into 2 or more nuclei, and you get energy produced as a result of that. We use that mostly in power plants. There are some forms of the nuclear bombs that use that, so weapons. And we also use this in medicine. Most medical uses of nuclear stuff are using fission because it's easier to control. So really briefly, fission is extremely easy to carry out. You basically just let it run. You can speed stuff up a little bit. That's what nuclear power plants do. But you kind of just let it do its thing, and it just happens. However, it does have some dangerous waste that takes thousands of years to become safe. Fission reactors have been mostly safely operating since the 1960s. There's been a couple meltdowns. We'll learn about those in class. But overall, it's been running for 70 years pretty safely. And it currently accounts for about 5% of the Earth's total electricity produced. America, that's slightly higher, but as a whole, as Earth, we're about 5%. These fission byproducts, the reason we need to be worried about this a little bit, this will become one of our main topics, is that fission produces really, really, really small amounts of this waste that lasts for thousands of years. So fission reactor also doesn't produce a whole lot of waste. I don't have the exact numbers on it, but if you think like coal is producing all this carbon dioxide and tons of soot and stuff, well, a fission reactor is going to produce a ton less. Like we're talking maybe a barrel or 2 a day instead of thousands of pounds. However, it lasts for thousands and thousands and thousands of years. Right now, some countries are trying to use it in other types of reactors, while some countries, such as the United States, are just burying it and hoping that it doesn't leak out into the environment. Some alternatives to nuclear include, of course, our typical gas and coal. Hopefully you know enough about those. But I want to throw some other alternative energy sources up here, stuff such as biomass, hydroelectric, geothermal, solar, tidal, wave, wind, and wood are really common ones. Biomass is really taking off. We'll once again learn about more of this during class. Let's see. And that's the end of my notes. Good timing with about 30 seconds left. We'll dive into some of these issues a lot more during class. Really, at the end of this BP, what you're going to want to answer, though, is on your own, using your own knowledge and opinions, is should we use more nuclear energy or shouldn't we? So I'll leave you with that thought. Have a good day. We'll see you in class.